Open Systems. What it does is let you design your network of resources for today's needs and tomorrow's demands. IBM recently announced OpenEdition MVS. It combines the strength of MVS, the flexibility of open systems, and the diversity of the workstation. Whether you create it or take it off the shelf, applications that conform to Posix, Portable Operating System Interface, can easily be moved among varying platforms. Now, a discussion and demonstration of OpenEdition MVS.
Art, as the product manager of OpenEdition MVS, what do you see as the motivating factors that drove the need for a Posix interface on MVS?
Well, there actually were a number of them, Paul. The first one is pretty obvious, which is the government requirements for compliance. It's no longer possible to bid in our government today unless you're compliant to a standard they call FIPS 151. That standard says you must be compliant to Posix standards 1 and 2. In Europe, that compliance requirement is going to become even bigger in 1994 as they start to require compliance to XPG, which is really a superset of Posix, adding all of the national language considerations into it. So that one was pretty obvious. The other ones, which is where we're really after, is to enable MVS to be in a distributed environment. And by that I mean we have to support DCE. In order to support DCE, you must have a good, excellent, in fact, Posix implementation in MVS because DCE is dependent on those services. The third one, which is really the most important, is to enable new applications to run on MVS. The Posix interfaces are a subset of Unix, and as we evolve those interfaces to become a full, what I call commercial Unix system, we're going to enable those applications to run on MVS.
Would you care to share with us your thoughts on the customer acceptance of OpenEdition MVS?
Customer acceptance has been really overwhelmingly positive. What we're allowing customers to do is leverage the investment they've already got in an MVS system. Without this support, customers who have an MVS system and want to run a new application that is written to a Unix interface simply cannot do that on MVS. What we're allowing them to do is keep that investment not only in their hardware and software, but also in all of their system management and programming skills, and bring in these products to run on MVS that can't run there today. We're also allowing them to now tie into a large amount of workstations and other operating systems that they can't do, and we're doing that through DCE, but again, we're allowing them to leverage that investment they have in data and programs on MVS and get access to it throughout that network.
What I'm doing here is OpenEdition MVS, and what I'm showing you is the X11, the X Windows motif, and I'm accessing the mainframe via TCP/IP. How I do that is to log on to an AIX terminal. Through TCP/IP, I log on to TSO, and through TSO, I access the Posix environment under MVS. In that environment, the things I can do are the graphics that you normally see in a Unix environment, and also I can do the TSO commands that you normally see in a TSO environment. I have a hierarchical file system where I can access data from my Posix personal computer or my Posix mainframe, or I can access the MVS data on the MVS mainframe. This allows me to do many things. As you can see, I have multiple graphics images showing. I'm also able to issue C commands, I'm able to do C language coding, I'm able to do Posix commands, and I'm able to do file transfer, anything that's available in the TCP/IP environment. It really leaves me with a full function PS2 or mainframe attached to MVS.
Don, what are some of the key attributes of the new hierarchical file system that is offered with OpenEdition MVS?
The file system is a byte-oriented hierarchical file system, which is similar to what you would see running DOS on a PC. When we started doing the work, we considered using our Unix file systems that we would port to MVS. But these file systems were designed to run on what's called a UP non-interruptible kernel. They're not designed to run in a multi-processing box. Also, they were designed so that nothing could ever go wrong, so that, for example, if a user was using the file system and they were canceled by the operator for whatever reason, it would take down the whole file system. This was unacceptable. So we built a file system from the ground up based on DFS-MS. We took advantage of the HSM support for migrating data sets. We also built in the integrity so that you could cancel a job and not cause file system damage. We also had to look at typical Unix systems require a function called fscheck to be run every time you start the Unix system up. And this goes through and scans all the data. Well, we might have a file system with terabytes of data, and you couldn't tolerate the time to go check that. So we've built in the integrity of the data so that it doesn't need to be checked.
I understand that the end-user interface is very similar to a Unix interface. Would you give us an example and talk about the results?
Okay, well, here on the screen you see a shell environment that a user would be in, and they're typing in an ls command. The ls command shows the contents of the user's current working directory. It lists the files in the directory and the access permissions. This is the exact same output that the user would see if they were running on a Unix system, regardless of the make. The shell environment provides a consistent interactive environment, just like MVS users are used to running in TSO and ISPF. The shell environment is that similar environment for the Unix user. So you could bring a programmer right out of college that was brought up on a Unix system, put them on an MVS system with this shell, and they would immediately be able to be productive as they then learn more about MVS or continue to use the Posix interfaces.
Don, in your opinion, what is the most important thing about OpenEdition MVS to our customers?
The most important thing is what it's going to give to the customers is in the area of vendor applications. Right now, there's thousands of applications that have been written to these Unix or Posix-like interfaces for other operating systems, for PCs. Once we have this Posix capability on MVS, there will be these thousands of applications that can be ported to MVS. So now customers, instead of having to go off and write their own applications, they'll be able to buy these applications from vendors. Because the vendors are going to be able to have their applications run on many more platforms, they'll be able to sell it cheaper. So the vendor gets an increasing market, the customer gets a broader choice of applications at a lower price. Everybody wins.
India, Bravo, Mike, and Alpha
Advanced
priority message.
strategic intelligence means accurate information to analyze yours and your adversary's technology, strengths, and capacity. I'm General Tom Kelly. As Director of Operations for the Joint Chiefs of Staff, I relied on those accurate technology assessments. These days, there's a lot of technology changing hands. Figuring out how it might get used and how it will perform in an uncertain future is the role of advanced strategic intelligence. Now IBM offers advanced strategic intelligence on mainframes. Accurate information to analyze the performance and capacity of IBM machines and the competition. LSPR, IBM's large system performance reference, lets you, the customer, accurately measure your future mainframe capacity benchmarked against your individual workload projections. Batch, online transactions, engineering, and scientific. IBM has had LSPR, Advanced Strategic Intelligence, on mainframes for years. But until now, it's been confidential. Now it's available to you.
From India, Bravo, Mike.
Call your IBM representative to get it. You can't afford not to.
Bravo, Mike. Identifier, Lima, Sierra, Papa, Romeo. From India, Bravo, Mike.